Forensic science is where the intersection of science and justice occurs, transforming physical evidence into courtroom testimony. It bridges the gap between scientific discovery and legal truth through rigorous methodology and cutting-edge technology. From ancient civilizations to modern laboratories, forensic science has evolved from basic observation to sophisticated scientific analysis. This journey marks the transformation from subjective judgment to evidence-based investigation, forming the backbone of today's criminal justice system. Forensic science applies scientific principles to investigate crimes and legal matters, integrating multiple disciplines for comprehensive analysis. It serves both civil and criminal law by providing objective evidence in legal proceedings with measurable accuracy. The term forensic originates from the Latin word forensis, meaning of the forum or public. In ancient Rome, the forum was the center of public life, where justice was pursued through transparent examination of facts before an informed audience. The marble columns of Roman forums witnessed the birth of systematic legal argument, where evidence and oratory combined to seek truth. These ancient spaces established the precedent for public examination of facts that continues in modern courtrooms. Mathieu Orfila and Alphonse Bertillon were revolutionary figures in forensic science. Orfila established toxicology as a forensic science, while Bertillon created the first scientific system for identifying individuals, revolutionizing police record-keeping. Francis Galton and Leone Lattes made significant contributions to forensic science. Galton proved fingerprint uniqueness, laying the foundation for modern identification, while Lattes developed blood analysis techniques crucial for solving cases. In the 1930s, J. Edgar Hoover recognized the need for standardized forensic analysis across American law enforcement. He established the first National Forensic Laboratory, creating centralized expertise that local agencies could access. Edmund Locard formulated the principle that every contact leaves a trace, revolutionizing criminal investigation by providing scientific justification for collecting trace evidence. This principle underlies every aspect of modern forensic investigation. In Lyon, France, Edmond Locard established the world's first police crime laboratory in 1910. This modest space became the birthplace of systematic forensic investigation, proving that science could solve crimes previously considered unsolvable. Every crime scene tells a story written in physical evidence. Understanding how to read this story requires systematic methodology and scientific principles, transforming chaos into ordered investigation through established protocols. Crime scenes exist in three dimensions: physical space, time, and human interaction. The primary scene holds the highest concentration of evidence, while secondary scenes provide crucial context and additional evidence for comprehensive analysis. Crime scene roles include suspects, victims, witnesses, accomplices, and investigators. Each plays a crucial part in the investigation, from providing evidence to analyzing and documenting the scene for forensic analysis. Evidence can be testimonial, physical, or trace. Testimonial evidence is influenced by memory and perception, while physical evidence provides objective information. Trace evidence connects suspects and scenes through microscopic materials. Evidence proves crime occurrence, links suspects to scenes, corroborates testimony, and exonerates the innocent. It provides scientific proof that clears individuals falsely accused of crimes, ensuring justice prevails. Behind yellow tape, forensic investigators document, photograph, and collect evidence for rigorous laboratory analysis. Each piece of evidence tells part of the story, revealing the truth about what occurred at the crime scene. Modern forensic science encompasses numerous specialized fields, each applying specific scientific principles to analyze different types of evidence. These disciplines work together to solve even the most complex criminal cases. Fingerprint analysis is a reliable form of human identification based on unique patterns that remain unchanged throughout life. Modern technology can search millions of prints, accelerating investigations and identification processes. DNA profiling revolutionized human identification, providing objective evidence of identity. Techniques achieve 99.9% accuracy, making DNA evidence extremely reliable in court proceedings, transforming criminal investigation. Ballistics experts analyze firearm markings, trajectory, and rifling marks to identify specific weapons with high certainty. These microscopic marks are as individual as fingerprints, linking bullets to specific firearms. Forensic toxicology is a critical field that examines poisons, drugs, and chemicals in biological samples to understand their role in death or impairment. It combines analytical chemistry with pharmacology to provide vital information about substance exposure and its effects. Historically, Mathieu Orfila's work in arsenic detection established toxicology as a legitimate forensic science, paving the way for modern applications such as drug-impaired driving cases and product tampering investigations. Forensic pathology plays a crucial role in determining the cause, manner, and time of death. By examining injuries, diseases, and conditions, forensic pathologists provide essential information for legal proceedings. They classify deaths and estimate the time of death using various scientific methods, aiding criminal investigations and legal decisions. Forensic entomology uses insect evidence to estimate post-mortem intervals and understand death circumstances. This field applies knowledge of insect life cycles to criminal investigations, offering valuable timeline information. Historically, it dates back to a 13th century Chinese text, highlighting its long-standing significance in forensic science. Document examination involves analyzing writing characteristics, ink, and paper to authenticate signatures and detect forgeries. Albert Osborne's pioneering work established document examination as a legitimate forensic science, ensuring document authenticity and aiding legal processes. Trace evidence analysis examines microscopic materials transferred during criminal activity. By analyzing hair, fibers, soil, and paint, forensic scientists can link suspects to crime scenes, revealing crucial evidence that might otherwise go unnoticed. Microscopic evidence analysis involves examining hair strands and textile fibers under high-powered microscopes. These minute pieces of evidence can reveal powerful connections between suspects and crime scenes, telling the invisible story of criminal contact through scientific analysis. Systematic crime scene investigation follows established protocols to maximize evidence recovery while maintaining its integrity. Each step in this process is crucial for ensuring that physical evidence can effectively support the pursuit of justice. Securing the scene is the first and most critical step in crime scene investigation. By establishing boundaries and controlling access, investigators ensure that evidence remains in its original condition, allowing for systematic investigation to proceed safely. Systematic evidence collection involves photography, sketching, detailed notes, and physical collection. These methods ensure that all evidence is documented accurately, maintaining its integrity for analysis and court presentation. Chain of custody documentation creates an unbroken record of evidence handling, ensuring its integrity throughout the legal process. This meticulous documentation is crucial for evidence admissibility in court. Laboratory analysis employs sophisticated instruments to analyze evidence collected from crime scenes. Advanced equipment and techniques transform physical evidence into scientific data that can support legal proceedings, meeting stringent legal standards. Forensic scientists prepare detailed reports and provide expert testimony in court. They translate complex scientific findings into understandable terms, ensuring that their conclusions are clear and objective for legal professionals and jurors. Forensic investigators carefully collect evidence using sterile tools and proper containment methods. Each piece of evidence is documented and packaged according to strict protocols, ensuring its integrity throughout the investigation process. Throughout forensic science history, landmark cases have changed how evidence is collected, analyzed, and presented in court. These cases demonstrate the power and limitations of forensic science, showing how scientific advances can solve crimes and prevent miscarriages of justice. Leone Lattes revolutionized blood analysis by developing techniques for determining blood types from dried stains. His work laid the groundwork for modern DNA analysis, helping convict criminals and solve cases that were previously unsolvable. The O.J. Simpson trial highlighted the importance of proper evidence handling in forensic science. It showcased the power of DNA analysis and the need for meticulous documentation and laboratory procedures to withstand legal scrutiny. Kirk Bloodsworth's case demonstrated the power of DNA to exonerate the wrongfully convicted. It was the first instance of DNA testing proving innocence, highlighting the importance of reviewing cases where forensic techniques might reveal innocence. The John Benet Ramsey case highlighted the complexities of forensic investigation when evidence is limited or contaminated. It showed how different experts can reach varying conclusions, complicating investigations and highlighting the need for new forensic analysis methods. A forensic scientist presents evidence in court, translating complex findings into understandable testimony. This moment represents the culmination of scientific investigation, where months of analysis are distilled into clear, objective testimony that serves justice. Modern forensic technologies leverage cutting-edge tools to solve crimes with unprecedented speed and accuracy. From DNA sequencing to AI applications, these advancements are revolutionizing criminal investigation and expanding the boundaries of what evidence can reveal. Next-generation sequencing technology has transformed DNA analysis, offering faster and more detailed genetic profiling than ever before. This advancement allows for the analysis of degraded samples that were previously unsuitable for testing. With enhanced sensitivity, familial searching, and ancestry tracing, NGS opens up new possibilities in genetic genealogy databases, enabling researchers to identify connections through DNA matches and expand investigative opportunities. Digital forensics plays a crucial role in today's criminal investigations, dealing with computers, smartphones, and internet-connected devices. This rapidly evolving field requires specialized techniques to recover, preserve, and analyze digital evidence while maintaining its integrity for court presentation. From data recovery to mobile device analysis and network investigation, digital forensics provides the tools needed to uncover hidden criminal evidence. Artificial intelligence is revolutionizing forensic facial recognition, enabling rapid comparison of suspect images against massive databases. This technology accelerates identification processes that once required manual comparison by human analysts. Video analysis enhancement and privacy debates highlight the importance of AI-powered facial recognition in law enforcement applications, balancing efficiency with ethical considerations. Three-dimensional crime scene reconstruction offers detailed virtual reality models that allow investigators, attorneys, and juries to virtually walk through crime scenes. This immersive experience enhances understanding of spatial relationships and event sequences, providing a more comprehensive view than traditional photography. Laser scanning, VR integration, and jury education tools are transforming how complex crime scenes are presented in court. Portable forensic technology brings laboratory-quality analysis directly to crime scenes, enabling rapid evidence processing that can guide investigations in real time. These devices are particularly valuable in time-sensitive situations, offering field DNA analysis, handheld spectrometers, and mobile fingerprint scanners to identify unknown substances and assist in suspect identification on site. A forensic scientist can now operate a portable DNA sequencer directly at a crime scene, providing genetic analysis results within hours. This revolutionary technology enables real-time investigative decisions based on scientific evidence, bypassing the lengthy laboratory processing traditionally required. As forensic science advances, practitioners face increasingly complex challenges related to evidence integrity, analytical bias, privacy rights, and the appropriate use of powerful new technologies. Addressing these challenges is essential for maintaining public trust and ensuring justice as the field continues to evolve and integrate new methodologies. Proper evidence handling is crucial to prevent contamination risks that could result in wrongful convictions or missed opportunities to identify perpetrators. Preservation protocols and quality assurance are essential for maintaining sample integrity, ensuring that evidence collection, storage, and analysis meet the highest standards and can withstand scrutiny in court. Cognitive bias can unconsciously influence forensic analysis, leading to calls for blind testing, where analysts examine evidence without knowing investigation context. Mitigation strategies include blind and double-blind testing protocols, standardized analysis procedures, and continuous education on bias recognition, ensuring objective analysis and reducing human error. Balancing crime-solving capabilities with privacy rights is crucial in managing DNA databases. Familial searching and data security measures must be carefully regulated to protect sensitive genetic information while allowing for effective investigative use. Establishing appropriate legal frameworks and oversight mechanisms is essential to address privacy concerns and ensure ethical use of DNA databases. Forensic science must navigate complex legal and ethical boundaries, ensuring evidence meets legal standards for court admissibility and addressing technology limitations. Emerging technology ethics and professional standards guide practitioners in maintaining high ethical standards, balancing the use of powerful forensic tools with protecting individual rights and ensuring justice. The scales of justice, intertwined with a DNA double helix, symbolize the delicate balance between using powerful forensic tools to solve crimes and protecting individual privacy rights and civil liberties in a democratic society. This balance is essential for ensuring justice while respecting personal freedoms. Forensic science continues to evolve rapidly, incorporating artificial intelligence, big data analytics, and advanced biotechnology to solve crimes more efficiently and accurately. The future promises even more sophisticated tools while raising new challenges for privacy, ethics, and justice as the field pushes the boundaries of technological innovation. Big data and machine learning are transforming forensic science, enabling pattern recognition, predictive analytics, and automated analysis. These technologies optimize resource deployment, enhance public safety, and free human experts to focus on complex cases, all while maintaining ethical boundaries and ensuring justice. Future identification systems will incorporate multiple biometric markers, moving beyond traditional fingerprints and DNA. Retinal scanning, gait analysis, and ear geometry offer comprehensive identification profiles that are difficult to fake or circumvent, enhancing security and identification capabilities in forensic investigations. Environmental forensics applies scientific techniques to investigate crimes involving illegal dumping, pollution incidents, and wildlife trafficking. This field uses chemical analysis, biological assessment, and geological examination to trace contamination sources and identify responsible parties, addressing ecological crimes and regulatory violations. Global collaboration and standardization are essential for advancing forensic science, ensuring evidence compatibility across jurisdictions and legal systems. International databases, legal harmonization, and training exchanges facilitate evidence sharing and mutual legal assistance, while research collaboration drives innovation and expertise across national boundaries. Education and training innovations are crucial for preparing forensic professionals to meet the challenges of modern investigations. Virtual laboratory training, simulation-based learning, online specialization programs, and continuous professional development ensure that experts are equipped with the latest techniques and knowledge, maintaining high standards in forensic practice. A futuristic forensic laboratory features holographic displays, 3D crime scene reconstructions, automated analysis robots, and scientists working with advanced AI systems. This setup promises unprecedented speed and accuracy in solving crimes while maintaining the highest ethical standards, showcasing the potential of cutting-edge technology in forensic science. Forensic science stands as humanity's commitment to finding truth through scientific inquiry. As technology continues to advance, the forensic science community must maintain its dedication to accuracy, objectivity, and ethical practice. The quest for justice through science continues, and it depends on all of us to maintain its integrity and support its evolution.